Kia ora. This is a short overview of the assessment task that you'll get for the 90947 standard. You'll either get the SC1083Y1 or the SC1083Y2. So let's have a look at what you're going to have to do. First of all, you've done most probably the first four booklets of the different types of reactions. You have the combination reactions, the decomposition reactions, the precipitation reactions, and the displacement reactions. So we're going to look at one example of each one to see how you carry on with this. So, the assessment task. There are three parts to it. The first task is you either carry out a whole series of reactions to investigate those reactions, or you'll be given photos. You can ask your teacher which type you would like, depending on whether you've got access to the equipment or not. So you'll either have, as I say, photos to look at, to analyze the reactions, or you'll be doing them yourself. It's always more fun doing your own reactions. Then also you will have to carry out write a report on those reactions, because you've got to explain why a reaction you carried out is either one of those four reactions. Remember, is it a combination? Why? Is it a decomposition reaction? Why? Why is it, if it's a decomposition reaction, why isn't it a combination? So you go for what it is and why it is not another type of reaction. And then finally you'll be given a task just to make sure that you can use the solubility rules that are given in the task, so you don't have to remember them off by heart. So can you use them to predict whether a precipitate will be formed? So let's look at a combination reaction. Here's an example where you're heating iron with sulfur. So if you can see the iron, you will, I'm just going to draw on here. I don't know if you can see, you've got a yellow sulfur powder and the sort of darker grey of the iron, and you will notice that as you heat it, it starts going more and more grey. You will also get it starting to glow. Do you notice you have heated it, but then you stop heating as the reaction gets enough energy and it starts producing its own energy. And you'll notice in the final picture it's still glowing and all the yellow is gone. You will notice some yellow is in the test tube. That's because sulfur has got quite a low melting point and boiling point, and so some of it will evaporate. Now what you will have to do to show your chemistry knowledge, you have to write a word equation. So word equation is where you use words, but you still use the plus and you still use the arrows. So we took iron and sulfur, those are our reactants, and we formed iron sulfide. Notice the IDE, it's not an 8 because we haven't added oxygen to this mixture. And you will also be expected to write the balanced chemical equation. And in this case, it is already balanced, so you don't have to add any numbers. Now you have to write your observations, so you would have to say you needed to heat the reaction. You heated the reaction until the reaction started glowing, and then you could stop heating, and you would talk about the color change. Let's look at the next type of reaction. So what I want to also say, why we know it's a combination reaction is if you think of the iron and the sulfur, I've got two elements or two reactants, in this case they happen to be elements, and I form one product. So 2 goes to 1. That's how we know it's a combination reaction. Two elements producing one. They're combining to form one compound. Let's look at the decomposition reaction. The one we've got here is calcium carbonate. It's one of the hardest ones to decompose that still work. You have to heat it for quite a while. Now you'll notice in this one it's set up so that we can collect the gas that's given off. And in this beaker is lime water. Now I hope you remember after you've done your studies that when lime water turns milky, if you bubble a gas through it, the gas is carbon dioxide, because carbon dioxide reacts with the calcium hydroxide to form insoluble calcium carbonate again. Okay, so you notice over here in this photo there's strong heating and you heat all the way through. If you stop heating, the reaction stops. And if you notice, the lime water is slowly starting to become cloudy until you notice that it has become cloudy. So we know a gas has formed and that gas is carbon dioxide because the lime water has turned milky. So we know we have got two products that are formed from one substance, and that's why it's a decomposition. It's a thermal decomposition because thermal means heat. We have to heat it to get it to decompose. Okay, so decomposition reaction is when we have one substance breaking down to form two simpler substances. And we know we've got two substances because we know we have a gas, carbon dioxide, from the lime water. And, well, the calcium oxide is not so easy to see because calcium carbonate is white and calcium oxide is white, so it doesn't look as though there's much change. You would have to weigh it to see that there is actually a difference. You can perhaps see that you do still have some white substance left, but I agree this particular one isn't very clear. Right, let's carry on. Precipitation reaction. This is the third type of reaction you have to investigate, and this is when you have two solutions and you mix them to see if a precipitate is going to form. A precipitate is a solid substance that's formed because that combination of ions is insoluble. Now, as I say, you will be given the solubility rules so you can work out what it is. In this case, we get given copper sulfate, which is a blue solution. Sodium hydroxide, it's not really shown, but as we add the sodium hydroxide, it's a colorless solution. You wouldn't see that from these photos. But can you see we're forming a blue precipitate? Can you see the blue precipitate is being formed? What is also not clear, you can't really see that the blue has faded much, but if you were doing this reaction yourself, you will notice that eventually that blue would totally go as all the copper forms copper hydroxide. And again, you would write out the word equation, you would write out the balanced equation, and in this case you will have to add a number in order to make sure that the atoms are completely balanced on each side of the equation. Now, what you would observations is not only that there's a precipitate, but there's no energy involved in terms of heating. Can you see there's no Bunsen burner, no spirit burner? We didn't heat this reaction, and it's not glowing. There's no heat given off. So can you see how it is different to the combination reaction we had and the decomposition reaction that we had? Finally, the last one is a displacement reaction. Now, this is different to the previous one because do you notice we don't mix two solutions, we have a solid that we add to a solution. So in this case it's the magnesium that's the solid, and the solution is lead nitrate. So when we add magnesium to a solution of lead nitrate, can you see there's a change? There's a solid adding on, okay? And if you look at your piece of magnesium at the end of the reaction, it's not very clear, that you can't really see that the magnesium has got smaller, but you can certainly see that a black substance has formed on top of that, that magnesium ribbon, and that black substance is the lead. So how is this different to the precipitation reaction we just looked at? Well, before we had two solutions we mixed to form a solid. Now we have a solid plus a solution. Solution is AQ to form a solution and another solid. Before it was a solution and a solution to form a solution and a solid. So, and again, we don't see much change in energy. If you were carrying out this reaction, sometimes you feel a bit of heat coming off, but you wouldn't see that from the photos. Carrying on, let's look at now task 2. In task 2, you have to do all those observations you wrote down about the heat, whether you had a solid or a gas being formed, whether you could identify the gas as carbon dioxide. You must take all that information and you must write a report. So a good way to start a report is say what each type of reaction is. A combination reaction is where two elements or two substances combine to form one single substance, or two elements combine to form a compound, a single compound. Then you explain why it applies to a particular reaction. So when we had our iron sulfide, why was that a combination reaction? So we had our two sub-elements, iron and sulfur, combining to form one compound, iron sulfide. And then we'd have to use our observations to try and explain why it is a combination. So you could say, well, you had to heat it to give the energy for it to form, but it did react and it started glowing itself. That's different to a decomposition reaction because we didn't have to heat it all the way. So you explain why it is a particular type of reaction and also why it isn't another type of reaction. All these points are, by the way, I'm aiming for excellence, but I hope you will all try to aim for excellence. And then again, if it's a precipitation reaction, you would explain on those particular rules. And we will do an example at the end. So here's an example of why you said ions and sulfur. If we reacted those as a combination reaction, so you would state the definition. What is a combination reaction? And then you would talk about your observations. You needed heat to get it started, which is similar to a decomposition reaction. Remember the calcium carbonate. But when you did the calcium carbonate, you had two products being formed instead of one, as in the iron sulfide. And we know we had two products because we know the gas turned lime water milky. So we knew there was a particular one. And the difference between this one and a decomposition is we didn't have to heat it all the way. I did also sort of state, and if you really wanted to show how impressive you are, that sort of gas that's sort of coming off, that's actually just the sulfur that's boiling off, really, because you heated the reaction. And then the final task is predicting precipitates. So when you predict a precipitate, you must show you know what ions are present in solution, and then you look at the solubility rules. They are given to work out or to state which ions would be soluble and which ions are insoluble, and from that you work out a combination of ions which would form an insoluble substance and which one would form a soluble substance. So as an example of this, for example, remember we had copper sulfate and potassium hydroxide. So what is in my copper sulfate solution? I have copper ions and I have sulfate ions. What is in my potassium hydroxide solution? I have potassium ions and I have hydroxide ions. In case you're wondering, oh, I don't know my ions very well, a table of ions is given. So the formula OH minus would be there, or K plus. You must just recognize K plus as being potassium, of course, which can be tricky because it's a K doesn't relate to potassium very easily. So then you'd say from the solubility rules, all group 1 salts are soluble. Now, if you're not sure why I said that, it's because potassium is in group 1. You are given a periodic table, so you can look it up to find out what group it is in and apply the solubility rules. So if all potassium salts are soluble, it means that the combination of potassium and potassium hydroxide, must be soluble, and the combination of potassium and potassium sulfate, must be soluble. Then we look at the other side, where we look at now what other ions have we got. We've got hydroxides. Now, if you look at the solubility rules for hydroxides, it says all hydroxides are insoluble except for the group 1 hydroxides, because remember we've just said all group 1 all group 1 salts, which includes the hydroxides, are soluble. So all hydroxides are insoluble, which means if I add copper to a sulfate, a copper 2 plus ion to a sulfate, it will be insoluble. And so there's my insoluble prediction. It means that substance that's coming out there is going to be the copper hydroxide precipitate. Right. I hope this has been helpful to know what sort of thing is expected. Remember, the more detail you give, the more likely you can get excellence. Make sure when you work through the booklets, you understand what you need to do, you understand all the definitions. Please contact your teacher if you are not sure. Goodbye.